difference between the terms and see whether or not it's a constant common difference. If it's not, take it to the next step and perhaps it will be. Here we go. The difference is 2. The difference is 4. The difference is 6. Alright. If I go to this is one step. One step. Alright, now to the second step. Here. The difference is 2. And here 2. Alright, fortunately for us, it doesn't go to a third step, just to 2 steps. Alright, now, just like there was a linear expression to the one before, the last question we did, right, the one step has a linear expression for the nth term. Here, right, because it's a 2-step, our nth term is going to be, alright, now it's going to be quadratic. That means that must be squared. And then a term n to the power of 1 and then a constant. Alright, so we'll have an squared and then it's going to be plus bn plus some constant. And that's what it must look like. Because it's a 2-step process, not a 1-step process, and therefore a linear nth term. This is going to have a quadratic nth term. And we've got to find out what it is. Alright, well, we'll just start substituting like we did before. Here's our first, second, third. Alright, we've got 1, 2, 3 unknowns. 3. Dr. Budpot had 4 before because it was a cubic nth term. Right, we've got 3 this time. Alright, so when I choose the terms and then complete each of the numerical statements for them, right, we should get 3 equations in A, B, and C. They're the 3 unknowns. Alright, so let's see how we go. The first one, A1 equals 1 equals. Alright, the first term's 1. Alright, I put in n equals 1 here, I get A, 1 here, B, here, C is independent, so it's just A plus B plus C. The second term, A2. A2 is 3. But it's the second term, n is 2. Here, n is 2. Right, so when I put n equals 2 in there, I'll get 4A. Here with n equal to 2, it's going to be 2B plus C. And then A3, the third term in the sequence, what is it? It's 7. Alright, n equals 3 this time. Put 3 in here, I'm going to get 3 squared is 9, 9A. Here, n equal to 3, 3B plus C. 1, 2, 3. Alright, now, we've got a number of choices, determinants, Kramer, like we did in year 10. Right, I'm going to choose elimination. I'm going to take a pair of equations, eliminate the C. Take another pair of equations, eliminate the C. Then I'll get 2 equations and 2 unknowns, solve them just by elimination or substitution. Right, it might take a little bit longer, but if you're not up on your determinants, I'm not sure you guys are up on your determinants at the moment, perhaps it's a better way to choose this. Alright, so here we go. I'm going to take equation 1 away from equation 2. So equation 2 minus equation 1. Left-hand side working first. Here we are. Here it is. 2, here's 1. I'm going to take 1 away from 2. 1 taken away from 3. So 3 minus 1, 2 equals. A from 4A, 3A. Plus B from 2B, B. And C from C, and fortunately the C's drop out. Alright, so here now we've got 3A plus B is equal to 2. There it is, that's number 4. Alright, now choose another pair and generate a different equation in A and B. Alright, so this time I'm going to take equation 1 from equation 3. So this time it'll be 3 minus 1. Let's see what we get. Here, 1 taken from 7, 6. And here, A taken from 9A, AA. Here, B taken away from 3B, 2B. And where's the C? C taken from C, nothing. Right, here's number 5. Okay. Now, we've got choices. I have to solve that pair of equations, but there's only 2 unknowns, yes? Just the A and the B. Right, so we've got 2 equals 3A plus B, 6 equals 8A plus 2B. Alright, now, I'm going to take this one and double it and then get rid of the B by subtraction. So number 4 times 2. Let's see what we get. We get 4. Here we get 6A plus 2B. Right, that's number 6 now. Alright, now, here's the 2 we can work with. Alright, so equation 5, if I take 6, 5 minus 6 now, let's see what we get. 6 minus 4, 2. 8A minus 6A, 2A. 2B minus 2B, nothing. This is A must equal 1. Yes? Alright, now, if A equals 1, go back and substitute into any of the equations involving A. Right, here's a simple one to substitute into. Alright, so if I sub it in 4, so A equals 1, sub into 4, let's see what we get. A equals 1, I'll get 2 equals 3 plus B, like that. So, 2 equals 3 plus B. B is going to equal negative 1. Yeah? Alright, now, I still need C every time it eliminated each time. We've got A now, we've got B, so if I go back here, I can easily work out what C is. So sub back in 1, sub in 1, and what have we got here? 1 equals A plus B, well where's our A? It's 1 plus negative 1 for B plus C. Alright, that says C is equal to 1. Alright, now, what's the point of the problem? The point of the problem is to work out the A, the B and the C, and then what the general nth term must be. Well, here we are. I've got C equals 1, B equals negative 1, A equals 1. So I'll squeeze it in here, and I'll choose another colour. AN must be equal to. Alright, what's the A? The A is 1, so it's 1n squared, so it's just n squared. The B is negative 1, so it'll be minus n. And then the C is 1, so it must be plus 1. And there is our quadratic nth term.